Good evening, everyone.
Good evening, ma'am. You're audible now.
I'm audible now. Okay. Thank you. Thank you so much. See, I'm very sorry for the delays caused, but today we'll be starting with the first unit of robotics. I know we all are very curious to know about robotics and understand more about robotics. But let me tell you one thing: your journey is going to be very interesting. I hope you remember me. I am Sangita Menon. I have met you during the examination. Do you remember? Any one of you? Uh, there was a boy called as Banerjee. Is he there here? Long, tall boy.
Yes, ma'am, I remember.
Yeah. I remember you because you did it very faster. You did the practicals very fast. Okay, so nice meeting you all back again. And children's, this syllabus is actually more practical oriented. Clear? So you have to be. You can't miss lectures. Let me tell you one thing, because I know you all are going through your internship. Sorry. I know you're going through your internship and you have many things to be done at the same time. So, what you have to do is you have to start studying along with your internship only. Is the picture visible to you? Is it visible to you? Is my PPT visible to you? Yes, students?
No, ma'am.
Okay. Just a moment. I'll share. I'll share. Don't worry.
No, ma'am.
Okay. Now is it visible, students? Clear? That
Yes,
is
ma'am.
preparing for the basics of robotics. Okay, today we'll just go through the basics of robotics. That is, what does robotics actually mean, and what is the outline of your course? Okay, that is especially unit one. Is my PPT visible? Is the font visible? Do you want me to increase the font or so something of that kind?
It's perfect, ma'am.
Okay. Now see the content of robotics in your first unit, which you will be studying, is introduction, basic introduction to robotics, exploring the building blocks, that is the code, the electronics behind it. Then there is something in our practicals. We have something called as Raspberry Pi. How many of you are hobbyist programmers or hobbyist fellows who like to, do some R&D with Arduino and Raspberry Pi? Can you just, put your hands up? Not a single? Okay, no problem. We will actually read the different parts of, Raspberry Pi in detail out here, because we will be creating something called as headless vehicle, a headless robotic vehicle in our practicals. That is practical number one, which is there in your syllabus. See, I'll not be reading the entire syllabus for you. Please, I don't believe in doing that. So go to Mumbai University website. You will have semester 4 syllabus with you. Please download it and read it on your own. You have nearly 10 practicals, 10 to 11 practicals in robotics, wherein the first practical says that you have to explore the Raspberry Pi properly. What are the, pin structure, that is 40 pin structure, what does that Raspberry Pi do, and what it is on its own, that we have to study that as a first practical. So today is a practical session in your timetable, but because we have not yet touched with the theory part of it, that's why I will believe that we'll start first with the theory, then we will go and prepare uh, with our practicals. Now, the theory as well as the practical is similar. more or less, in the first unit. The first unit itself is a practical, and the first chapter itself is a practical in its own. Okay, so you don't need to worry if you miss the practical session, at least the first practical. Okay, but after that, please be present. It's my request to you, because they are interrelated. The topics are interrelated. Clear? And I hope BSc Computer Science students and BSc IT students have actually had IoT and embedded systems as a subject in the second year. Some would have had in the third year. If you are a drop, if you had drop, then in previous syllabus it was in second year, third year, but now it is in second year. So it is in second year, SEM 4. So now you would have studied a Raspberry Pi practical, wherein you had to, connect the Raspberry Pi with your CPU, with a desktop or something of that kind. But today in our practicals, we will be studying something different. So let's start with it. Now, with the introduction, if I say, then what exactly is robot for you? To, if I say that robot is an intelligent machine, then will that be the proper definition for it? Yes. Will that be the proper definition for it? If I say that robot is an intelligent machine, or robot is something which we build, okay, which we build, we create programs for it. Yes, somebody named Vishwakarma joined now. Okay, so please, students. Anyway, it is a 2 hours lecture. Join in time. Huh? Now, so we will write codes. We will write codes where we'll use sensors, where we'll use, we'll make the robot. We'll make the robot learn the surroundings, or identify the surrounding, identify the scenario in the surrounding. Now, when you identify the scenario in the surroundings, how exactly will you do? How exactly will you do? Now, see, what happens is, when you say, okay, I'll allow the robot to identify the surrounding, I have to exactly give a artificial eye to the robot to make it visible in make the surrounding visible to it. Okay, now because we are humans, we possess possess biological eyes, which is given as a gift to us by Mother Nature. So what happens is, we already can see the scenario in a proper way. Okay, but when it comes to our normal robotics, we are creating a machine where we intelligently write the code. Now, when I say intelligently write the code, means what? It is a machine which we create, or we write a set of rules or set of lines in the form of syntaxes. It can be any language. It can be any language, children. It can be in your basic Python, or it can be in R, it can be C, C++, it can be using robotic operating systems, or any basic language of our choice. But what we want exactly to do with the robot is, when we program a robot, it should be able to complete that task without human assistance. Okay, without a human assistance, and it should be able to do something called as take the decisions on its own to do a particular task. Okay, now if I say that I program a robot and it is completing the entire task on its own without my assistance, that time I will call that particular robot to be a autonomous robot. Okay, autonomous robot. So throughout this chapter, while we will have a formal introduction to robotics, that what is exactly a robot, okay, what techniques we have combined, and what is the little bit of code which we actually write, and the result, it results into creation of a machine, and that machine after certain period of time feels like a pet to us. Why we do say that it feels like a pet to us? Because it is human tendency. Once you get once you are thorough with the programming, then you go on and you do the means if one basic program runs properly, your curiosity increases to that level that you go and create the second level programming out there. Now, when I say I program a robot, or when I say I create a robot, then we should be aware of the coding as well as the error. As well as the error. See, if you understand basic concept of robotics, you might have seen certain robots which are operated through remotes. Now, this kind of a robot is called as a partially controlled robot, and this robot is actually known as a tele-operated robot. That is, it needs human assistance to take care of its, its functionality. It won't complete the entire thing on its own. It won't complete the entire module on its own. The directions that you have to go straight for a certain period of time, then take a turn. The explanation or the correlated steps, you can say, which we call as module programming in robotics, will be done through the assistance of a of a human, and that assistance will be done through a remote control. Either the remote is connected with a string, or it is Bluetooth operated, or it is your mobile device which is used, normal Android mobile device, which is used as a remote to control that robot. Now, sometimes we see robots which are just like a humanoid structure. That is, they appear to be like a humanoid structure. You can, the name of it, is there down the line in your textbook only. It is sorry, in your syllabus. That is created by SoftBank Robotics, and it is Noah. The name is Noah. Now, the newest version of Noah, or similar to Noah, is Pepper. Okay, again, it is by SoftBank Robotics only. You can see robots strolling in malls, especially in not in India but abroad, assisting customers to purchase certain things. They hold a tab which has a definition of the entire supplies inside the store, and that is explained with the help of the tab, and the tab is carried by the robot. The robot can interact with the human being that time. Now, when you have that kind of a robot, that example of a robot is called as a autonomous or fully mobile autonomous robot. Clear? So, is the basic difference understood, that there are two types of robot? One is operated with human assistance, and that is called as teleoperated robot, where the another robot is just flexibly moving, understanding the scenario, interacting with the elements in the scenario, and doing its functionality. Okay, is there any doubt in the first introduction? It is a very simple introduction that there are two types of robots. Now, on what basis rules do you create these robots? Okay, means if I say that if I want to know who created the first robot, then we have to jump into the history of robotics, and we have to know that where did robotics come from. And to your surprise, it came just from a play. Okay, a play means an English play called as Rossum's Robot. Okay, now this Rossum's World had was an Irish play, and in this Irish play, he wanted uh, to move, or he wanted to show a trajectory inclined jump of a human being from one side of the stage to the another side of the stage. And this was done around somewhere in 1912. And the word robot is comes from science fiction. It was derived from science fiction. But actually, the origin of the word is from a Czech word, which says that robo means what, robo means in Czech language, that is Czech language, it is slave. It means slave. Okay, but today you can see it is dominating human world. Okay, now why it is dominating the human world? Because you would have heard somewhere down the line author named Isaac Asimov. He coined the word robotics as to be means as to be the intelligent behavior explored in a machine, and that machine was called as robots. So, children, is it complex to understand? Is it complex? Is the way I teach easier, or do you have certain, limitations saying that it should be more easier, or it should be more said in a more easier way? Is it clear the way I teach you all? Yes, I want a feedback. Hello? I'm the lone one sitting out here.
Yes, ma'am, clear.
Okay, thank you so much. Now, thank you, children. Thank you so much. Now, if you peep into your house, okay, if you peep into your house, I mean to say, through peeping into your house means you stay in your house. At present, you're in a home only, and you're surrounded by so many devices. Okay, you use so many devices to actually take care of your lifestyle. Okay, so can you tell me one system? Can you tell me one machine which works entirely on its own without a human assistance? Any one machine? Yes, there are 32 students out here. Okay, it's a request.
Ma'am,
कि-
car manufacturing robots?
Yes, बच्चा, that is not in home. वो घर पे नहीं है
Okay,
ना
not at
समरवन.
home.
Yeah, not at home.
Ma'am, the robotic vacuum cleaners?
Yes, that is very, that is very, very modernized one. Today it is appearing, but if I say we had a machine which was long back used by my grannies, my mothers, and today I am using it very, nicely. It is something called as a washing machine. Okay, I don't relate that entirely to the robotics, but yes, it was a machine which evolved nearly so many years before, maybe long back in 1995 and all. There came a machine called as fully automized machine, washing machine, and once you load the cloth into it with a timer, it used to work so flexibly that today, you you get IoT based washing machines sitting in your workplace. You can done your work done. Okay, why? Because these processes are fully controlled by the device itself. It just needs a partial human assistance, and after that, what happens is the machine automatically revolves or rotates on its own without interrupting in between, interruptions in between, I can say that. Suppose if the supply goes off, then it will lead to an error. If the water supply is not provided properly, then that will lead to error. But for your understanding, for your for your ease, for your understanding, let me tell you that this is something which is the basic imagination that how could a robot work. कि एक बार उसको एक टास्क दे दिया, then it will not allow you to come in between, or unless and until you don't pause it, it will not stop working. Or if there is insufficiency in the infrastructure, then that time it will stop. Okay, so that is how it will work. Fine. That is very small. That is a very small thing. Okay, that is a very simple example to to initiate your imagination towards robot. But let me tell you that we use codes. We used codes to attach devices to this robot. But if I say the robotics engineer got inspiration from the human beings to create the robot. If I say Noah, if I say Peppa, these all robots, even your Sophia, it is similar to a human being. So where did this robot engineers got the inspiration from? For them, the inspiration is exactly human being. Whatever is the parts of a human being, similarly, they tried to create the robots. Let me tell you one thing. We all, if you start the biological body system of a human being, we have a controller which we relate it to the brain of a human being. We have sensors which we relate to the eyes, the ears, the tongue to feel and understand, to understand the taste, and the mouth to speak. So similarly, our robots also have various sensors through which they communicate with the world. Okay, they communicate with the world in a very flexible way. They try to understand the world around it, and then they actually, after understanding, they try to execute the code which is running inside it, and through this code they actually perform the task. Okay, now see, for a simple example, if I want a robot to open the door and walk 50 steps and take a turn towards the left or towards the right. So physically I'll have to measure the length, divide that into the steps. Okay, then I have to measure the angle which I want the robot to turn. I have to write the code and then burn it into the robot use controller, and then I will execute it. Okay, now if I want to create the same replica, which I say the headless one, what is a headless one? Okay, there is a concept called as headless robots. Headless robots are those robots which are not connected to the CPU or central processing unit of your computers. Okay, headless robots are one which can be operated through Wi-Fi fidelity, through Android mobiles, or they have the inbuilt computer in themselves. They have the intelligent compiler with them only, and because they have everything with them, they don't have to depend on anybody, and because they are, that reduces the processing, and because it reduces the processing, it is faster. Okay, now suppose I make a robot. For example, if I take Arduino, the oldest Arduino which I had to connect it with a USB port, and then I have to program it. I have to write all the codes in the language using Blink software, and once I code it with using C++ codes, I create a hex file, and then I burn it inside the controller. Once the controller is done, then I can do many functions together. Okay, one is blinking of the LEDs, the ringing of the buzzer. Okay, that means what? Displaying something. Okay, that means what? I will enable the robot to make to make it enabled with the vision technology, with the speech technology, and with the, you can say, with the conversational technology. Okay, in your slide, the second point is return. Yes. Yes, Tiwari, you're exactly correct. The lane departure that the cars use. Okay. Now, they, in some cars, they talk to us. Okay. They actually talk to us. They interact with us. They give us the obstacle while, especially when we take a reverse. Okay. Then, suppose if there is a herd, if there is a wall besides us, or if there is a anything, even a small animal coming in between, then it starts beeping. And in MG Hector, it is given as a, it gives a voice command saying that stop, because you have a cat behind you. Okay, like that, it gives you command. Fine. Now this all programming is done in the form of a chatbot and placed inside it in the main processor M5 of the cars. Okay, then the autopilot mode, that is also programmed. Now these are all autonomous EV vehicles. Okay, so something of that I can't say that it is to that level we'll be able to create, but a replica of that, educational version of that, we can create. Clear? Now most of the real robotics which we enjoy, sometimes we demonstrate it using voice control. Sometimes we demonstrate it with you can say a laser control. These all are a part of your basic robotics only. Now on what principles do you exactly distinguish between these robots? Now you know it very nicely. If you have Alexa at home, you can command it for certain things, and you can make certain things happen automatically without human assistance. Okay, just a speech is required. Once you train it or once you load it, then you can use it throughout your entire life. Okay, now the most real robots in our home and industries, is very eye catching. And it's not cutting. Why? Because they stand on their legs. Some have wheels, some are not mobile, like some are not moving, some have sensors, but they are all very nice. They assist you to flexibly get your job done. Now a self-regulating robot or a fully regulated uh, you know uh, industrial boiler or air sampler, okay, fans in your home, which are a part of everyday life, they are not threatening. No, they don't look tedious to you, no, because you have an air purifier. When the oxygen level reduces, automatically it turns on and it supplies the amount of oxygen in the room. And once the air is up to that level, it is automatically put off. So when it is working, it is not causing a chaos to you. It is user friendly. Okay, now there are 3D printers, there are arm robotics, then there are toys, okay, which are very exciting, and people, children use it nowadays. They are so friendly with it, that they would like to use it as a part of their life. Okay, now moving on to the next one, the next slide, that is what will be the hardware which you will use. See, you have an example out here which is a VR. Okay, sorry, AR. Now, the hardware simply comes down to the input requirements and the output requirements. For input, you need sensors. Okay, similar to the eyes, to understand the scenario where you're standing. At present, you might be sitting and listening to my lecture from the comfort of your home. So either you might be on your couch, you might be on your, on your study table. So the scenario which you are in is visual to you because of the presence of the sensor called as eyes to you. Similarly, if I have a robot, I want to control it, or I want to make it take a data, then from the an existing environment, I need to give it something called as peace. Okay, please remember peace. Let me spell it. It is PEAS. Okay, what is peace? Anybody? किसी को भी idea है? See, P is perception. Who is this? P is perception. Okay, P is perception, E is environment, A is actuator, S is sensor. Okay, what is perception? When I see something, what I understand through the visuals, I perceive it to understand the environment in which I am. When I understand the environment, I try to move in that environment to make some changes. And when I move in that environment, I use my legs. Okay, because I'm a biped human being. When it comes to robot, it has wheels, it has legs. Okay, it has caster wheels, or you can say stratified wheels, any kind of wheel, but it has wheels for movement. So one which cause positional displacement is called as actuator. Then one which receives information is called as sensor. So piece is uh, what? Perception, environment, actuator, sensor. So this is the parts of the robot also. There are two parts in this. First is actuator and another is sensor. Environment is something which is not a part but it is required. Okay. Then what are the other parts of a robot? What are the other parts of the robot? It is controller, which is the main decision making box. Then you have the embodiment, the body of the robot. Okay, that embodiment normally is a chassis. Excuse me, a chassis. What is a chassis? A chassis is that edge kind of structure. The chassis is a edge kind of structure. Let me see if I have the image. I'll show it to you. Uh, just a moment. Is it visible, children? Yes, students, is it visible?
Yes, ma'am. Visible.
Okay. The see this part. See this part. Okay. See the mouse. See this part that is the dark brown structure out here. Okay, this is the chassis. Okay, it looks like a H, it looks like a T. Okay, this is what will embody, it means it will hold all the parts. Now see, this is the wheels. Okay, these are yellow wheels. They are called as caster wheels because they are used, they have depending on the design they're called like that. Now this yellow small structures out here are called as motors. Now this is the motor controller. To control these motors, I need a controller, and that is the motor controller. This is a beautiful Raspberry Pi in between. Okay, which is, I'll just increase the size so that it will be visible to you properly. See, this is the Raspberry Pi. Fine. Now this is, these both are sensors. One is an IR sensor and one is a camera sensor out here. Now this is called as a strip. This is a color strip which is used for indicating different colors. That is, it is a strip of color, the LEDs together. Now these all are sensors which we use. Okay, and now this is the power supply unit. Right. So this is the basic part. Suppose if you do the practicals, you will need all this together. You will need to assemble this together on this dark brown color board, and this is how your vehicle looks like. Okay, this is how your vehicle should look. This is the 3D cross-sectional view which is taken on from top. Okay, why? Because here comes your raspberry. ये बीच में जो है, this structure is called as the raspberry. This is the camera out here. Two cameras here, two cameras here. Okay, this is the battery backup. Fine. If you can connect power bank also to this, mobile power bank also to this. Fine. Now this is just a assembly of a hobby robot, which normally we use. Mostly you would have done it in your schools and all. But if you are not done, don't worry. We'll be doing this. This is the final thing which we have to do in our second practical. Fine. But for the first practical, try to understand that if I want to make it a input unit, then I want sensors. Okay. I want sensors. If I don't want to make an input unit, then just a moment, I have to represent it. Very simple language, I'll tell you. If you want to make an input unit should be something hardware which helps the robot to receive data or to feed the data inside the robot's brain, and that is nothing but your sensors, which help us to measure the environment, creates collect the sample properties and feed it in the form of data, and through that data we try to understand the atmosphere. It's now when you have an input, the processor will process it automatically, and then it has to be sent to the process output has to be sent to the output to give some output. So what can be the output here in case of a robotics is, suppose if I measure the length, then I can say that for this particular length, walk in the straight line. So that can be, if I have 7 steps, then for 7 steps I will ask the robot to give the motors to be given a particular speed, and in that speed it will drive the entire setup which I showed you just now, will move on that line, and through that line movement, it will say that from this end to that end the distance is so much, and this is the square meter in form of square meter, this is in the form of number of tiles on the floor, and this is the quality of the output. That it will try to create a map of that entire area. Okay, now suppose if I want to, this is one application. Suppose if I want to that from this end to that end, the robot moves and puts on some wall, and then the heat is generated and it will alter the environment. Then I need a temperature sensor on the robot itself, which could indicate, yes, this is the temperature at present, this is the initial temperature, and this is the final temperature. So I can go and put off the heater at present. Okay, so now this all has to be done on the by the robot itself, and taking the decisions on its own, and by making the movement on its own. Clear? Now, if it takes decision after taking input from the environment, that time the decisions will be autonomous, and that's how it will control itself to create an output. So this is something called as advanced robotics, and this is something in your next section. Okay, now what we have learned till now is the general overview of robots. Clear? Then some specific remarkable things which goes around with the robots, and what are they capable of, and which was the first autonomous robot. See, the first autonomous robot which was sent in the form of in a vehicular form was the Mars robot, and it was sent onto the Mars to find some human existence or animal form, and it had been a favorable robot for the makers, because the way it adapted the scenario or the environment of Mars was very distinguished, and because they were successful in doing it there, they tried to implement the same in industrial use, and they didn't wait for a single you can say a single use, or means once it is devised, once it is created, it's not like that it can be used only once and left over. This machine, which is called as a robot, one day it will, if you teach or train them to do certain things without any haste, it will be performing the same task repeatedly every day, and the accuracy, the precision, the time taken, the speed of delivery, it will increase day by day. Okay, it will improve day by day. That is the basic difference, children, between the robots and human being. Okay, how many times when told you study everything on a go? No, we are lethargic. We are really lethargic. But the robot doesn't has these kind of sensation because it is not trained emotionally. It is trained on the data which it receives from the input. Clear? Now let me show you the first example of the robot. Okay. Now this fellow is called as COG. From Massachusetts Institute of Technology, COG was an attempt to make a human-like human-like robot which had movements and sensors. Okay. Now, what are these sensors? Can you see this block structure out here? This is the sensor. Let me make a slideshow so that you can see. Okay, clearly. Now, see, this is the sensor here. This is the visual sensor. You can see speakers. It has got arms in the form of linear actuators. It has, for movement, flexible movement, it has got a spring which creates its body, and this it is a standing structure. It is a standing edge structure. Okay, okay. After that, you have something called as Asimo. Asimo is a robot which was created by Honda. It was the replica of human being because it used to walk and talk like a human being. Now, this kind of structure where there are legs, they are called as biped robots. Now, they are even called as passive walkers. What is the other name? They are called as passive walkers. Asimo, if you see here, you can see two white dots. It had two cameras to perform object avoidance. Now there is what we use in today's autonomous vehicle is that only when you put it in an autopilot mode and leave it for and that kind of property or that kind of gesture of a vehicle or a robot is called as obstacle avoidance or object avoidance. Okay, there is two property. One is object avoidance or obstacle avoidance, and second is obstacle collision. Okay, we won't want that the robot should go and hit and collide itself. It should damage itself. Then what is the purpose of programming it with such finish? So what we have to do, we have to make the robot avoid the collision. So we can put up at whatever speed it is, we can make it, we can pause it or freeze it for a certain moment of time. Now there is a gesture. If people are working in IT departments, your attendance normally is is done through your face detection. Okay, it's normally done through. Yes, Shamim, what happened? Huh?
Ma'am, we can only see the Robo One screen still.
Okay, you can only see Robo one screen. Just a moment. Now is it presentable? Now can you see Robo 2?
Yes, ma'am.
Thank you, thank you. Just a moment. Okay, now Robo 2. This is Asimo, which I was talking about. Now, this Asimo has the property of obstacle avoidance. What it has obstacle avoidance, and because of this obstacle avoidance, what happens here is that it won't go and collide with anything, it won't spoil anything. Now, it has why it happens that it stops at a particular moment at an instance of seconds and it doesn't hit anything or collide with anything. It is because of the laser distance sensor. Okay, and it helps to identify the object beforehand itself because of the lidar. Okay, it is called as laser detection, and ranging. Okay, now that is how you will be avoiding to make mistakes while moving independently. Okay, when we say avoiding mistakes to move independently means our robot will not go and collide because of the LiDAR, laser detection and range. Okay, that is the full form of LiDAR. Now, it has laser distance sensor, so it can sense the floor also. Okay, it can sense the path also. It can sense a lane, it can sense a tree in front of it, any object, any static object, any dynamic object, any moving object. Every look and corner can be identified. Now, this is something which is used in vacuum robots. Okay, this sensor is used fully in vacuum robots, which is used for cleaning the floors. Um, it is called as RoboVac. Okay, and it is normally in metropolitan societies, most of the homes don't have it. Okay, now because it uses a light laser sensor, it follows the mark with, suppose it has its own way of marking the floors using the IR sensors, and it maps the entire room once it is set initially, before when it is new and you set it in map mode and leave it inside the room, it will sense the entire room for map. It will create a map on its own for the entire room, and after that it will scan the entire area and it will clean. Asimo is programmed with English commands as well as Japanese commands. Okay, children. Now coming on to the next thing is your next robot, that is Noah. Okay, now what is Noah? Noah is a SoftBank robotics. It is 58 centimeter tall and it is used for playing, you know, it is used for learning as an assistant, it tutor. It plays, it plays with the users. It program for, you can even reprogram it. Now it is trained to play football, or you can say soccer. It has sensor which detects its motion, and it has it has a mechanical actuator which assist it from not falling down, because it is a biped. If you can see, it is a biped with so many actuators connected, and it has a stable connection for its feet. You can say a stable linear connection in its feet. It is using speakers and microphone for voice processing. It has multiple cameras which perform better and faster with respect to Asimo. Okay, so any doubt till now, children? Okay, now coming on to the next thing is Boston. Okay, now this is actually called as, you can see it in, you can see the advanced version of this in some vehicle ad also, something called as Jimny. Okay, the advanced version of this. Now this is Atlas from Boston Dynamics, and it has two legs. It is natural looking for movement. It has a LiDAR, okay, laser radar array, which it used to sense the entire environment, plan it properly, move properly on that, and then it avoids collision. The advanced part of it is this. Okay, if you see, it is there in today's technology of electronic vehicles. Now this is Boston Dynamics Big Dog. It has a four-legged robot or a quadruped. It can walk, run. It is more stable. It can stand upright. Okay, once it is pushed, as an egg, it stands properly. Even if it is pushed, it can regain its structure. It can come back immediately and start walking in the condition it was. It can walk in any condition environment. That is, it can walk on ices too, snowed areas also. Okay, so children's, this is the introduction to the first unit. And see, this is the Mars rover, the rover which went on to Mars very early. It was in the earlier years, in 1920s. It went on to the Mars. it is having, instead of legs, it has wheels. Now these wheels, if you see the design of these wheels, they are etched in a proper way, a different way. Okay, why? Because they are kept simpler so that it moves faster. It can scan most of the areas of the Mars, and while doing this, it uses legs. And in case if something goes wrong, it is able to, communicate with the user, saying that this part is ruptured, or this part has needs a correction. There is a connection, loss of connection in this area. This has to be displayed in the robot. Okay, that time it becomes a fully headless robot. Each wheel on this rover has a self-assistant motor. Okay, that's why this design is a bit complex. It is a big, it's a bit clumsy. It's having so many devices connected around. Now wheels are arranged to provide maximum grip, because you see, depending on the area, if you check the robot, which is a vacuum cleaner of your home. Normally, the vitrified tiles or normal flooring tiles are very, very, they have a smooth texture. So that the wheels used will be different. Whereas if I want the robot to climb a terrain, a mountain, or a rough surface, there the wheels will be different. Why? Because it is a headless robot. Once I land it into the scenario, it will not be assisted by me. It has to take care of its own, accumulating the data, connecting the data, gaining all the data from the scenario, and working on its own. Okay, so this is the brief classification of different robots and how it is different from a human being, but it is inspired by a human being. That is given in this first chapter of your unit 1. Okay, now this is, thanks for listening, and for more information I'll load these videos onto my YouTube channel, that is Code with Sam, and you can find it out there. Fine. So any difficulty in your first lecture? Yes, students, any difficulty in your first lecture? Is it hard to understand? Because see, today only the introductory part, only the introductory part. Yes,
Hello,
why then
ma'am.
Atal?
Can you please load it in the Google Class, whatever?
I have to create a, sir. Very good evening, sir. I will load it. Okay, so I'm nice to see you here. Now,
Sir, please, can you do? Because Google Class is very easy to locate.
no problem, sir. I have to create a class. Can anyone do the favors? Anyone, I want to self volunteer. मैं किसी को appoint नहीं करूँगी. Okay, anybody. बहुत सारे लोगों का नाम मुझे याद है. विष्णु है. Then, yeah, I remember. Yes, Tamim, no problem. You can create a class. Okay. Or else wait, I'll only create a class. You can create a group, Samin, if you want. Samin, you may create a group, and please keep the track of the attendance, because I there were 32 people, and I was, because Jam ma'am told me more are there. This is a compulsory subject, na? Where are you all? कितने सारे हैं? अभी किधर है बाकी के? Okay, no problem. I'll take a screenshot of everything, and send you on the classroom only. I'll create a classroom today and send the link to the main UDCS SEMFO group, and from that you can join my class. You will find this PPTs also out there. You will find all the documents related to it. If you don't have a textbook, I'll send you the e-textbook also. Don't worry. Fine. And thanks for your patience listening. We'll continue in the next lecture. Any doubts? Any doubts anybody has? Because see,
Ma'am, I have a question.
yeah,
Ma'am, how are we going to perform the practicals for this subject? As you mentioned, everything is mostly practical based. in its robotics. So
See, listen, children, child, I have my own kit. I have my own Raspberry. Okay, so if you don't have a Raspberry Pi, you please observe it properly. Okay, you might be attending it through any device, no problem. If it is a phone, if it is a laptop, put it into auto recording mode, and I'll explain you stepwise, detailed. Means I don't consider this to be a class of MSc, because it is a new syllabus to you. So I will make it very easy for you. Okay, first I will go on with discussing the Raspberry Pi structure with it, the entire PCB. uh, I'll have to actually grant 1 or 2 lectures in doing that. You have to understand all the system, the board properly, Raspberry Pi board. Then you have 7 to 8 sensors which has to be connected to it. Okay, I will demonstrate everything in my class, and one day in a month we will meet in the university's campus also, so that time we will physically do it. Clear? But yes, stay committed. When I call you, please come, because yes, I'll take a leave and come.
yeah, ma'am, that will be very helpful.
हाँ, because I know ये इतना आसान नहीं है जैसे दिखता है। वो मुझे आता है, तो मेरे लिए वो it's like a butter, but for you, you have to actually do the connection. You have to understand the kit properly, एंड यू हैव टू एक्चुअली स्टडी द किट। ये पार्ट कौन सा है, 40 पिन का आईसी है उसके ऊपर, उसमें बहुत सारे कनेक्शन है, उसमें एक कार्ड है जो वाईफाई कनेक्ट होता है, उसमें एक कार्ड है जिससे आप दूसरी डिवाइसेस को कनेक्ट कर सकते हो। तो ये सारी चीज़ों को पहचानना है, पहले हार्डवेयर को जानना है, फिर वो हार्डवेयर को प्रॉपरली किस हार्डवेयर का क्या फंक्शनैलिटी है वो अंडरस्टैंड करना है। और उसमें एक 40 पिन स्ट्रक्चर है, वो 40 पिन स्ट्रक्चर क्यों है, उसको यूज करके मैं कौन सा सेंसर कनेक्ट कर सकती हूँ, कौन सा पोर्ट को मैं आउटपुट के लिए यूज कर सकती हूँ, कौन सा पोर्ट मैं इनपुट के लिए यूज कर सकती हूँ, और वो कैसे वो चैसिस पे असेंबल होगा, वो कैसे मूवमेंट होगा, मूवमेंट होते समय क्या मुझे एरर्स आएंगे। ओके, ये सारी चीजें आपको एक्सपर्टीज करना पड़ेगा, क्योंकि वाइल डूइंग द प्रैक्टिकल, आउट ऑफ द 10 प्रैक्टिकल यू विल गेट दिस ऑल्सो। मीन्स कैसे, देखो असेंबल करना बहुत आसान है, 4 चीजें आपको दे दो, आप वो बोर्ड पे चिपका दोगे और उसे कनेक्ट कर दोगे एक दूसरे के साथ, उसे टेपिंग कर दोगे लाइक मीन्स वोल्क्रा टेप के साथ, तो वो गिरेगा नहीं। लेकिन सपोज एक चीज डैमेज हो जाएगा, वही वहां पे आता है कॉम्प्लेक्सिटी। सपोज चिप के एक पिन उड़ गया, सपोज आईआर सेंसर का एक कनेक्शन छूट गया मूवमेंट के टाइम पे, तो वो क्या आपका रोबोट वो उस एलईडी डिस्प्ले पे प्रॉम्प्ट कर सकेगा क्या, क्योंकि रास्पबेरी पाई खुद से कंप्यूटर है। तो क्या आपका रोबोट ये बता, मीन्स इट शुड पुट एज अ टैग दैट दिस इज डिस्कनेक्टेड। तो इसके लिए वो फिनिश चाहिए प्रोग्रामिंग का, और ये पूरा प्रोग्रामिंग जो है आपका पाइथन में ही है, ठीक है। और लिनक्स बेस्ड है, उबंटू बेस्ड है, सो यू डोंट नीड टू वरी। ओके, सिर्फ आपको कैसे कनेक्शन करना है उसे समझना है। मैं डरा नहीं रही हूँ, देखो बच्चे लोग, मैं आई एम नॉट स्कैरिंग यू, ठीक है। आई विल मीट यू ऑफनली सो दैट योर डाउट्स आर क्लियर। ओके, लेकिन संडे है, छुट्टी है, नहीं आना है करके आलस मत करना। वैसे भी तो कॉलेज जाते नहीं हो ना, कम से कम इसके लिए आ जाओ, ठीक है। आई विल बी देयर इन द यूनिवर्सिटी, फाइन। चलो, नाइस मीटिंग यू ऑल। प्लीज शामीम टेक द अटेंडेंस। ओके, चलो, बाय एवरीवन, हैव अ नाइस डे, वील मीट ऑन सैटरडे।
Thank you, ma'am.
थैंक यू सो मच डियर।